All right, guys, here we are again, Chris Fonsi and Greg Ruiz, to talk about good practices in API design, part 2. So, Greg, I have a dog.
Hey, you know what?
I am a dog lover.
I am the same. I have a wonderful Wheaton Terrier who's learned to become a boat dog, in fact.
Really?
Yeah, strange thing. She actually likes to swim.
I have a Chesapeake Bay Retriever who is a huge water dog. Just loves swimming. And I also have a boxer that has nothing whatsoever to do with the water. We decided that since we like dogs, we're going to use dogs as our example domain, if you will, for talking about API design. And we figured that this was probably a pretty good example to use because it's one that's kind of outside of a lot of people's comfort zone. Sure, we all, most of us anyway, like dogs, and a lot of us have dogs. But it's not something you normally think of in association with APIs.
Right, but actually, it is an API. As we interface with our dog, we're actually performing some API calls. You feed your dog, right?
I do feed my dog.
You walk your dog.
I do.
You pet your dog.
I do.
But there's a lot of things, though, that you do, maybe even subconsciously, with your dog that you don't think about. And if we start trying to put that into a practical API design, what we probably find out, I don't know, I grew up with dogs, but as I began to get old enough to have my own and be responsible for their care, I found out that there was a lot of other things that I had to do. And you sort of find that out organically as you go along, right? Just something as simple as, when you bring that puppy home, a chew toy might be a good idea, right?
Yeah.
And if we put that into perspective of an API, we might come up with, all of these things we see on screen as potential API calls. But it's very quick when we look at that screen to understand that there was not a lot of forethought and planning that went into the design of that API.
I could just imagine that if you were trying to write an application that interacted with dogs using this particular API, it would be an incredible pain.
Well, yeah, and that is the main goal, right? Is to make sure, we talked about it in our design principles, that things were obvious. Things aren't obvious with these calls. We're talking about some things that really you've mixed verbs in with your resources, and in such a way that basically the only way you could interact with this API would be just sheer rote memory. In fact,
there's no pattern.
I've seen this slide a million times, and I can't even tell you all the things that are on there, and I should be able to memorize those, and I can't.
I agree.
So, but that's us and talking about dogs, right? This doesn't actually happen in the real world, does it?
Well, it did once upon a time anyway. There's been some people out there that have made API designs that are perhaps less than optimal. This one, for example, is one from a large payment provider that I believe that since this time they've actually designed their API. So it's a little bit more conformant with what some of us might consider to be best practices in API design. But once upon a time, they had an API that looked kind of like this. And you can see that this is just like the memorization exercise that you talked about.
Well, and not even just memorization. There's things that just don't even make sense from that designing for the obvious kind of perspective that we were talking about. Callback. What does that do?
Call what?
Yeah, call what?
Void what?
Yeah, void what? Yeah, exactly. There's transaction search.
Yeah.
Are we talking about actual payment transactions, or the transactions with the API or databases? Or there's nothing. There's no pattern that I can grasp onto here to understand what this API does.
Yeah, and I can vouch for this. I've actually tried to use this API in the past, and yes, I was able to be successful, but not without a certain amount of pain, and that's kind of what we're trying to avoid here.
And I'm sure that with that particular API, you would have to have some really great documentation.
I think so. Definitely true.
Not saying we don't want great documentation anyway, but
also true. Also true. Documentation is one of those things that I think every developer needs. Not every developer reads, but it's nice to have.
Absolutely.
So let's kind of frame this conversation around API design in the context of dogs. Since we both have dogs, we both like dogs. It's a convenient topic. It's a little bit out of the ordinary. So it really kind of forms a good basis for thinking about design in a way that's not hindered by previous ways of thinking that we might seen in our day-to-day lives.
All right.
So we're going to start out by kind of framing this conversation in terms of something called the Richardson Maturity Model. This was a model that was put together by a guy named Leonard Richardson some time ago. And his goal was to kind of point out some of the most significant value points or design points in the REST dissertation that Roy Fielding had written. And this is actually a really good model for thinking about REST. I think the thing that I would say in response to this model, though, is that it kind of presupposes that REST is kind of the be-all, do-all of APIs, right? And I think there's certainly a lot of good things to be said about REST. It puts forth a lot of really core principles that are, things that we continue to use even today, right? But it's not necessarily, the ultimate API design specification, if you will. There's a lot of other things to think about that go even beyond the model. But it's a really nice way to think about the things that REST brings to the table that are really things that we should take to heart in API design.
Right. It's sort of our mental checklist as we're going down that path of designing that API. Hey, did we do this? Did we do that? Did we think about this?
Right.
Guiding principles.
Absolutely. So let's take a look at the first step of the model. This is Richardson Maturity Model Level 0, the swamp of POX, or plain old XML. In the very beginning, the Richardson Maturity Model says basically that, in achieving level 0, you've at least implemented your API on top of HTTP or HTTPS. Now, this is not a particularly high barrier to to achieve, right? So it's pretty straightforward for people to get to this point. But this is kind of the foundational point for a lot of the things that we'll talk about, both in terms of REST and RMM, but also in terms of just API design in general. Right?
Absolutely, yeah.
So if we step up to the first place in the model where there's really a substantial amount of design, if you will, it's this concept of using resources. Resources basically are a way to think about domain objects, if you will, in whatever particular domain, dogs in our case, right? So when you think about resources, there's basically two ways to specify resources, if you will. As you might expect if you've done any sort of programming in the past, there's collections, of course. In this case, we talk about dogs as being the collection, the aggregate of all dogs that we might be thinking about. Right. And then a mechanism that's required for specifying the identifier of a particular dog.
Right.
So a resource identifier, if you will.
Exactly.
And these are really kind of fundamental concepts in API design and in the REST dissertation as well, because they form the foundation for thinking about objects that you're designing around, right? This is dogs in this particular case. It could just easily be orders. It could be customers.
Products.
It could be cars.
Absolutely.
Literally, it could be anything, right? And as long as you've got a consistent mechanism for identifying those things, you can use this model.
But did you notice what we both did there?
Waved our hands.
Well, besides that, we spoke in the plural.
We did indeed.
So I think that's sort of one of the important best practices, if you will, or common design patterns that we see out there today, is the use of plurals to describe the collection. Mm-hmm. Right? We see this even in the real world, as you're pointing out in the slide. We have check-ins at Foursquare and deals at Groupon.
But Zappos didn't do it.
Yeah. Huh. So what do you make of that?
I think they just looked at that and decided that product made a lot more sense in their particular case.
Well, as we pointed out early on, there's no right or wrong here.
Right.
There's just simply recommended best practices. And I don't know, let them do it the way they want to do it. But for me, I think plurals are better. And I think we generally agree here at Apogee that plurals are the way to go in that first resource, that first level of the resource.
Yeah, well, collections, just the very concept of collections implies plurality.
Absolutely.
So I think that's a good way to think about it.
But the other thing that we want to make sure of is, as we begin to think about, okay, what am I going to name this? Mm-hmm. We there's a fine line between too general and too granular. Mm-hmm. We sort of have to find a happy medium in there. As we point out, things.
It's a little general.
Just slightly.
Not necessarily intuitive when you're thinking about dogs.
Right. But, is a dog even a thing? No, but it's an animal. How about that? Is that better?
No. Not really.
Because there's too many other things that could be animals as well, right? Dogs sort of hits that happy medium, but because if we go too granular, what'd you say you had a boxer?
I have a boxer.
So we've got boxers, but then what do I do with my terrier?
Yeah, or my Chesapeake Bay Retriever.
Right.
I have no way of handling that.
So I think what we're saying here is as we begin that initial planning, we want to make sure that we find a happy medium between far too general, but also not going all the way down to the granular detail that limits us in our abilities.
And I think as people think about a lot of different object domains, if you will, for the most part, the correct level of naming kind of tends to settle out especially when you follow some of the design principles that we talked about earlier and kind of think broadly about your domain. Right?
Exactly.
If you kind of take that larger view, then some of these things shake out. So I don't know that there's exactly rocket science in thinking about naming.
But what do you do though, when you have to have, you and I, we're owners of dogs.
Mm-hmm.
How do we approach those relationships, that association?
Well, that's one of the things that's particularly powerful about this collection resource identifier strategy is that you can actually nest these things in different ways to represent relationships between objects. So in the example that you just used, we talked about owners. Maybe my name is 5678 in somebody's database, right? Mm-hmm. And this also says that this particular owner has a collection of dogs.
Right.
Now that collection could be empty. It could have 2 in my case. It could have 1 in your case. It could have 10. But this at least allows for the representation of the relationship between owners, or more specifically a particular owner, and the dogs that they happen to own 0 or more.
Right. Now, but there's a fine line there too, right? Because we're starting to see our resource string sort of building here. Mm-hmm. And I can envision maybe wanting to drill even further down in the knowledge of that dog.
Yeah.
What's the best approach there?
Well, it's actually okay to do this drill down, as you called it, mm-hmm. right? I think once you get to maybe 2 to 3 levels deep, however, it becomes unwieldy because it's not clear exactly what the relationship is. You're ending up with a path that could potentially be quite long.
Right.
And it becomes unclear as to exactly what it is that you're trying to accomplish with this particular API request.
Right.
And so generally we would say that once you get past 2 or 3 levels deep, if you will, in resources and identifiers, then you should probably think about doing things a little bit differently.
Right. In other words, we made that funny, or laughed at that funny quote early on about digging the hole.
Yeah.
So we don't want to keep digging the hole deeper, right? We need to have that different approach. Move the hole. There
Just
you
move
go.
it.
Right.
Yeah.
So we're talking about then going back to sort of, I came from a traditional SQL database background.
Mm-hmm. As did I.
So we're sort of talking about back to the query, right? Mm-hmm. Changing the way we're attacking our resources.
Yeah. So resources and identifiers are very reasonable ways to create path-based queries, if you will, for APIs. But there's other types of parameters that you may want to specify on APIs that don't necessarily match up to this notion of resource collections and resource identifiers. So let's take something like dog colors, for example. I mean, I suppose it's possible that we could put together something like, dogs, Ben, colors red, or something like that.
Right.
But it's so unwieldy to do that. And so, certainly one of the things that we would propose would be that you start thinking about subsetting collections, as we did in this particular case, by using query parameters. The color, the state, what they're doing, where they happen to be at this particular time, or really any other thing that either allows you to not extend the path too far, or doesn't necessarily fit into the path-based resource and resource identifier collection.
Well, and there's an added benefit there, right? Because right now we're talking about, I'm getting everything back, the entire payload, if you will. I have everything that I ever wanted to know about my dog.
Yeah.
But this also allows us then to give partial results as well, right? So that we could just say, hey, you know what? I only want to deliver back the color, or the dog's favorite food, or whatever it might be. So that I'm giving the developer the option. Right. Does he want it all, or does she only want a piece of it?
Yeah.
Right. And that's, I think, that designing for flexibility as well.
Mm-hmm. Yeah, this is another way where query parameters can potentially be really helpful. In the previous example, we talked about using query parameters as a mechanism for kind of subsetting a search, if you will. The example we used was a collection of dogs, and we just happened to want the ones that were red.
Right.
But in this case now, we're actually saying we found actually what we want, and now we're trying to figure out what information about each one of those
Exactly
we want to
right.
retrieve. And there's a concept called partial response, which a lot of APIs have implemented, that allows you to actually specify those pieces of the
Exactly.
response payload that you'd like to receive.
Right.
Now, you could probably argue that making the request to receive a partial response is just as resource intensive as retrieving the entire response. But that actually kind of depends on what's going on in your
Exactly
particular
right.
API.
Exactly right. And I think again, as I mentioned, it's all about the flexibility and designing our API in such a way that, remember the control aspect, that I as a developer am in control of the way that I want to use your API.
Absolutely true. So using something like partial response then allows you to say, for example, that I only want the name and the color and the postal location attribute or postal code attribute of the location object. So you actually have the ability to specify even parts of nested objects in, say, a JSON response
Right.
to an API.
I think that makes perfect sense.
Yeah.
So I think I've got a pretty good grasp. I hope you do as well on this first part of designing our APIs. I think we've got something coming up called verbs.
We do indeed. The next level of the Richardson Maturity Model talks about the use of HTTP verbs, and we'll chat about that in a bit.